Hey scholars, welcome back to week 23. So this is going to be ELA Lesson 1, and what's kind of cool is we're going to a new unit, so we're going to be learning about a lot of new cool stuff. Like if you like science, we're going to be learning about a lot of science stuff too, so I'm super excited about that. So I'm going to go ahead and share my screen. This time it's not the iPad, it's my web browser, because we're going to look at how Earth affects us. So what I want you to do is look at the picture. How do Earth's forces affect us? Well, let's go ahead and look at this student who is going down this slide. What forces are affecting him? Now, you haven't had any formal learning on this, at least that I know of, so we'll talk about it, is think about gravity. Gravity is a force on Earth, and this student is going down the slide because of gravity. It's like if you jump up in the air, you're always going to come down. Or if you remember our moon, watching the moon landing back in the beginning of the year when we were still on distance learning. Remember, you saw how they would float a little? That's because there's less gravity on Earth. So I think what's important is for me to talk about what a force is. A force is a push or a pull on an object caused by another object. So I have my phone. If I drop it, I gave my phone a force, and then I let go of the force, and gravity made the phone hit the table. Don't worry, I didn't actually drop it. Just showing as an example. So gravity is that force that pulls things down. That's why we were all on the ground, because of gravity. But there's also another thing, is speed. So let's think about speed. I noticed some of you guys were running around trying to race each other when we were on recess, 6 feet, of course. And some of you were like, oh yeah, I ran faster than him. That is your speed. It's the distance an object moves in a certain amount of time. So if you're going in a car at 60 miles an hour, or if you're running at 5 miles an hour, that is speed. And which one's faster? The car. The car is usually faster. So what direction is the boy moving on the slide? What force do you think is pulling him down? Well, it would be gravity. And how could the boy increase his speed? What could he do to increase his speed? Well, this boy could push on the slide, pushing his body towards the bottom of the ground. If he puts force to go to the ground faster, then that's going to cause him to go faster. Okay. And we'll talk about some of this in class too, because I want to hear your guys' ideas, because all of you deserve to be heard. All right, cool. So I'm going to ask you guys a question at the end, so make sure to hold tight because it's going to go in your Seesaw journal. Okay. So we're going to go to the next part of my lesson, which is, let's go back. It's the background. We just built the background. That's good. Now we're going to go to build the concept with oral language. So this is going to be our vocabulary words. You'll see the cards on the wall right behind me, but we're going to discuss them here too, so you know what the vocabulary words are. So I have 8 words here. We'll start with amazing. Jason made an amazing flip in the pool. Oh, well, good for me, I guess. No, I'm just kidding. Okay. Oh. All right, let's go ahead and look at oh wait, no, not that. Routine. Okay, so if something is amazing, it is very surprising, or it makes you feel wonder. So when Jason made an amazing flip in the pool, you're like, whoa, that's crazy. His whole body flipped. That's amazing. So then you can see what have you seen that is amazing to you? That is a question I want you to think about. Amazing. Force. The force of my kick made the ball move far. The force of my kick made the ball move far. A force is a push or pull that can change how something moves. So I want to give you guys an example of that. Okay, let's look at me. I have this paper clip, right? If I don't give it a lot of force, I can make it hop a little bit, right? Well, if I give it more force, I can make it go up. I can make it touch the ceiling. I can make it touch the ceiling. I could also give a lot of force, just throw it behind me. See? So how much force you put on something is how far it's going to go. So I can put light force, just very light, or I could just throw it really far, just depending on how much force you have. Okay, let's go back to our share. Okay, what things take a lot of force to move? Well, when things are heavier, they usually take a lot more force to move. For example, Mr. Cannon moved all of these tables by himself. It took a lot of force because the tables are made out of steel, made out of heavy wood, made out of very hard material. So I couldn't just lift the table, put it over my shoulder, and take it with me. I had to push it. I had to push, and then I had to pull to get into the right spot. All right, let's look at the next one. Measure. I can measure my height with a ruler. If you measure something, you find the size or amount of it. We didn't do our measurement chapter this year because we just don't have enough time, but that's where you would use something like a ruler or yeah, it's not out here, so I don't want to go waste time trying to find it, but yeah, a ruler, something like that could measure. When you go to the doctor's office, you get measured by the doctor or the nurse practitioner, and then they use the height from the top of your head. All right, let's look at the next one. Objects. There were a lot of objects in the toy chest. Objects are things you can see and touch. So that's a bit general, meaning that a lot of things fall into that category. Because my pen's an object, this remote's an object, that paper clip I threw over my head's an object. So I want you in your seesaw book, in your seesaw or your notebook, I want you to tell me the biggest object that you have seen that is a toy. I want you to answer this question or this statement. What is the biggest object you've ever seen that is a toy? So what you're going to do now is you're going to pause the video, go to your seesaw, and answer the question. But don't submit your seesaw yet because there might be another question, okay? All right, so pause the video now and come back when you're ready. All right, and we're going to be back. Okay, so let's look at the next one. Proved. Wyatt's big hit proved he knew how to play baseball. If you proved something is true, you showed that it is true. That's funny because usually I try to keep the vocab words out of there, but Wonders thinks you need to hear the word true twice. So if you prove something is true, you show that it's true. So for example, if I told you my pen is green and you're like, prove it. And I show you, look, my pen is green. I prove to you that my pen is green. You can prove almost anything if it's true. All right, let's look at the next one. Speed. The car moved at a very fast speed. This is a Formula One car. Maybe. I'm not too good with cars, but I've seen Formula One once or twice, and that's what it looks like. That car can go really fast, over 200, 250 miles an hour, which is a lot faster than we're allowed to go. So, so the speed of something is how fast it moves. So there are some things that move at a slow speed. I know some of my students move at a slow speed when I give them something to do they don't want to do. But that's okay. I convince you to move at a faster speed. Okay, let's look at the next one. True. It is true that an elephant is the largest land animal. True. If something is true, it is a fact and not made up. So, Mr. Cannon teaches in room 4. That is true because I teach in room 4. Mr. Cannon can have up to 12 students at a time, even though he doesn't. That is true. Mr. Cannon is a teacher for 2nd grade. That is true. So when we're looking at truth, it is a fact and not made up. So what is the opposite of truth? Well, that would be a lie. Weight. Not like weight here, like weight, like how heavy something is. The weight of the pumpkin made it heavy to carry. The weight of something is how heavy it is. So like I was saying with these tables are really heavy. I can't lift one off the ground all 4 legs by myself. Maybe 2, but not all 4. Heavy. What can you do to find the weight of something? Well, you could use a bathroom scale if you're weighing yourself. The doctor can use a scale to weigh you. Yeah, pretty much scales. Scales will tell you how much something weighs. All right, cool. So we're back to amazing, which means we're finished with oral language. All right, now we're going to go to, after I find it, we're going to read our story. And I'm excited because my favorite types of books to read are nonfiction books because I like to learn about things about the world. So we're going to read about a nonfiction book. Remember, nonfiction means it's true. So as soon as it loads, we're going to read about how magnets work. Magnets are super cool because they have charges and you can stick magnetic things to them if their attractions are opposite. When I was a kid, I used to get a magnet and I would try to find iron filings in the sand and then I would put them in a plastic bag and take home. It's a lot of fun. All right. So, did you know magnets work? We're reading an expository text, which means it's a text that tells us about something that is true. That is our genre. Our essential question is, how do Earth's forces affect us? We're going to read to learn about how magnets help us. And I'm going to give you a second to get your bearings straight so I can pull up my magnet story on my book as well. That way I can get everything you need. Okay, let's see. Okay, I just want to make sure I have the right. Okay, just trying to find the right page, guys. Sorry. Okay, let's see. All right. Okay. Let's go ahead and open this up. I got my book. I'm ready to go. So, the notes that I would like you to take but we're going to do this in class because I just want you to hear the book, but we're going to do a lot of the note taking in class and on that Zoom. So what we're going to do is talk about how magnets work. Did you know magnets are all around you? Magnets help you do amazing things. So amazing, amazing. Remember, amazing means something extraordinary. Keep reading. See if you think magnets have surprising uses. Magnets pull. Look closely and you will see magnets can be found on a can opener. The magnet attracts or pulls the lid off the soup can. A push or pull is called a force. There is also a magnet in the refrigerator. It pulls the metal in the door to make the seal tight. Do you know how? Remember, a force is a push or a pull. A magnet's force pulls objects made of metals called iron and steel. It will not pull other things. It will not pull a wooden pencil or a plastic toy. A magnet does not attract all items. You have proved or shown magnets can pull some things to it. Why is this true? Two ends of a magnet are its poles. Notice, look, we have a bold word. That's a text feature. And we also have a picture with labels like North Pole and South Pole. Every magnet has a North Pole and South Pole. Have you ever played with trains that have magnets? Sometimes you try to put the two train cars together, but they repel. This means they push away from each other. When you turn one of the cars around, the two cars snap back together as quick as a wink. That's right. If you played with these trains, you know it's true. When the train cars push away, two of the same poles are facing together. However, if you have to put the north and south poles together, they will snap together like the train. Magnets can be powerful. We know that magnets can move objects, but does the heaviness of an object matter? Can magnets move objects that have different weights? Yes, they can. Scientists are using magnets in new ways. People often wish they can travel at a faster speed than a train. So think about it. Weights are something, how heavy something is, and a speed is how much distance something is covering. There is a new train that uses powerful magnets to travel more quickly. Magnets lift the train above the track and push the train forward. The train appears to be moving as fast as lightning. Scientists have measured these train speeds. They are much faster than the trains we know. Can you imagine what magnets will help us do in the future? Yeah, this is cool. So basically, there's magnets underneath the train and on the rail, and it causes the train to lift up and it'll push forward. It's super cool. So that is the end of this story, and we're going to go over some of the essential questions in class because that's something that needs to be partner-based. So the last thing I want you to do is I want you to write about one thing you learned about magnets. I want you to write about one thing you learned about magnets. All right? So go to your Seesaw book, go to your notebook, and write one thing that you learned about magnets. And as always, have a great day, and I'll see you later.